Hi guys, Mr. G here once again. Let's just take some examples based on the three theorems which we have discussed so far. All right. In the diagram below, D is the midpoint of the chord AB. So we must just indicate already if this is a midpoint, then that means this line here, AD, is actually equal to DB. And of course, we are given that they are perpendicular and C is on the circle. So if AB is 30, so the chord itself has a length of 30 centimeters and CD is 5 centimeters. So the line CD is actually 5 centimeters. Calculate the radius of the circle. So we have to actually determine the radius of the circle. And it's one of those problems actually which you will get, and in all truth and all honesty, is not that difficult. It's quite straightforward. And now just try and pay attention. What I suggest usually is that you always set up a T table, because in Euclidean geometry you are actually supposed to state reasons, and actually the questions it's usually the last question. Euclidean geometry is usually your last questions, few 3-4 questions in the exam paper. So, and they will even give an instruction that you must give reasons for your answers for questions 8, 9, 10 or so. All right. So I always suggest you have a T table. On one side, you're going to have a statement, and on the other side, you're going to have your reason or reasons. So, right now, what we've got to do here is it's actually some construction. So let's just suppose the center is somewhere there. So we just have to do some construction here, and I'm going to use a different color to construct my lines here. All right. So the first line that I'm going to construct is from B, and then to the center. The next one is from A to the center, and I'm using the same color because those lines are both radii, so they are actually equal. So then I just construct another one there, and now I put in some labels. In my labels, I will indicate that actually this is given, so CD is given, or DC, right? And we are told it is actually 5 centimeters. And if AB is 30, then that means AD is 15 centimeters and DC is also 15 centimeters. That's important to note. Now, I know definitely there's a right angle, okay? Because I know the radius is actually perpendicular to a chord. And I mean, it's the converse of the first theorem that we did, because I know this thing bisects, okay? Bisects the chord, so that angle should be 90. In any case, we are given a 90-degree angle. So if we use angles on a straight line, that angle still becomes 90 degrees. So I'm just showing you the different ways to look at this. Now, what's important is to note that the radius of this circle, R, is actually the line, let's name this O. So it's actually the line OC. Now, I don't know what this value is, so I'll just put an X there because I don't know what that value is. So you can see it is actually X plus 5. That's what my radius is. So what I mean by that is that this line here and the line OC is actually 5 plus X, that unknown value. And that's what I have to calculate actually. And I also know this is my radius, okay? This is my radius. Those lines are equal. So the radius is also actually AO and OB or BO. That's another important information to note. Now, the next thing that I'm going to do, which will come to my rescue, and this is the case, of course, if you've got a right angle triangle, is the fact that, well, if I take X, okay, X squared actually, plus 15 squared should actually give me the radius, which is OB squared. But I know now OB is actually X plus 5 centimeters. So that's just using Pythagoras, all right? So my reason here will just be Pythag. And then the next thing that happens is I have one equation, I have one unknown. So all is nice and easy. I just have to simplify. So this is x squared plus 225. And this is x squared plus 10x plus 25. And of course, you can see now, a nice thing here is that this x takes care of that if you're to group like terms. And so we are one milestone out already. Now we've got this thing here. If we group like terms, we're going to be left with 200, okay, is equal to what? 10x. And of course, I'm going to divide by 10, and you will agree with me then that x should be 20. And so that means this thing here is 20. Therefore, the radius r, okay, let me write it here. Therefore, the radius r is 20 plus 5. And what is that? It is actually 25 centimeters. Oh, might just be important to throw in the units here, 25 centimeters. So that is basically, guys, your approach when you want to use some of these theorems. The theorem here is that the radius, if the radius is perpendicular to what? To a chord, then it bisects the chord. We borrowed from that. And in fact, that this idea, this construction that I've done is what we're going to use to actually prove this theorem. And remember, we'll do the proofs later when we have done some riders, okay? So I hope you catch the glimpse of this, and the theorem rather stays in your mind. Cheers.